Hello, everyone, and welcome back for another great session. This time, please welcome Edith Puclla. It's her first time at Codegarden, so let's have a standing ovation for her. Come over. Take it away.
Thank you so much. I'm so happy to be here and so happy to make it. I had flight conflicts and all that things, so I'm happy that I'm here. I'm also happy that you are here. So let's start with this talk. Today, I will share with you a journey about how managing database containers with Kubernetes operators and Docker evolved over the time. So we are going to do like a little history from the beginning, Docker, Kubernetes, and then how we arrived to Kubernetes operators. So we'll see. I'm Edith Puclla. I am from Peru. Who knows Peru? Who here Peru? Okay, it's in South America, llamas, we have vicuñas, mountains, the weather is really nice. And I moved UK the last year with Global Talent Visa. If you are also interested in that, you can reach me out and talk about that. So I'm from, I work as a technology evangelist at Percona. Percona is a company that provides open source database software, supports, and services from MySQL, PostgreSQL, and MongoDB. And we are the ones who develop Kubernetes operators for databases. So we are running databases on clusters of Kubernetes. Okay, I'm also CNCF ambassador, Docker captain, and open source contributor for Kubernetes website. In my free time, I try to translate the documentation from English to Spanish to make it more accessible for people in Latin America. And recently, I joined to the Kubernetes Shadow release 1.3. It means that I am helping them to make the release available, the 1.3 release of Kubernetes. You can find me in Twitter, LinkedIn, and all the social media. Okay. In this talk, we will cover the basics of Docker, as I told you, Kubernetes, and how we can deploy an application. We will also see the standards resources and their limits, and Kubernetes operators. We will discuss the important parts like custom resource definition, custom resource, OLM, controllers, as well as the operator framework, operator hub, and capability models. Let's start. In this life, we know that IT and the technology evolves very fast. If you are already out of the market 1 year, this is like 10 years. I feel it in this way. And it's more important than ever to have ways to deploy and manage applications that are scalable these days, efficient, and reliable. Docker and Kubernetes are leading this path and this transformation. They offer powerful tools to package our application into containers and manage the deployment across multiple platforms. Containers. I know many of you already know containers. Could you raise your hand if you, yes, all of you. Yeah, a container we know is a isolated process that runs in our operating system. To make this possible, we need a containerized technology like Docker, for example, and on top of that, we have libraries and dependencies, and also we have our application running on that as a main process. By 2023, 70% of the companies were using multiple containerized applications, according to Gartner. This shows how important and popular container applications has become until now. Supporting this, also Docker is rated as a most loved and most wanted tool for development in 2023. This is according to Stack Overflow. Maybe one of you was part of that statistics. Okay, let's see Kubernetes. Using Kubernetes with Docker has made managing our containers more easy. Kubernetes also automates many tasks, so we don't have to do it by hand. It can automatically deploy or identify things that are happening in our cluster, and it can repair it. Kubernetes also keeps our application running smoothly by quickly fixing any issues. When a pod is with an issue, we can recover it easily and automatically. And also help us with monitoring our application, especially when we are using microservices. And the best part of this, I can add it, that we have in Kubernetes an active community and a wide adoption. They are always supporting our community and our innovations in Kubernetes. In Kubernetes, okay, we pass this. In Kubernetes, we have three main things. We have a lot of things, many components, resources, objects, but we are going to focus on three things for this talk. So first, let's talk about pods. Pods are the main and basic unit of the Kubernetes. They are a group of containers from one or more containers together running and sharing the same network and also the same storage. Next, we have deployments. The deployments is where we define how our application is going to act. We define the desired state of our application, and Kubernetes make it possible to add replicas for the spots and ensure that everything is running okay. Finally, we have services. The services are policies that we create for our pods so they can know how to access each other and ensuring applications are reachable from and can communicate each other. Now let's see an example of how we can containerize an application using Docker and Kubernetes. We will use a voting application, as you see, and we will vote for our favorite snack, chips and chocolates. How many of you prefer chips? Yeah. And how many of you chocolate? Yeah. Okay, I'm hungry already. Okay, and this is an example of a voting application. This app consists in two parts. We have a voting interface, like you see. You choose chips and chocolates, and we have another web app to display the results, which is this one, Result App. This is what we want to do. First, let's start containerizing our applications. So we are going to put just each application in one container. Voting app, which is the web application developed in Python, in this case, that provides to the user with two options, chips and chocolates. We have Valkey. Do you know what's Valkey? Valkey is an open source that is replacing Redis, I can say. Redis closed the code, so Valkey now is an open source, and we at Percona also supporting Valkey. Valkey let us save database in memory. It's an open source, as I say. And we have the worker. The worker is going to take the vote that we did in voting app. It's going to process, and it's going to save the result in a persistent storage, which is PostgreSQL. PostgreSQL has only one table with a number of votes for each category, chips and chocolates. And finally, we have the results, which is in Node.js, and where we are going to display the answer. Until now, we have already containerized our applications. You see, we have each application in each container. Next, we are going to create the pods. To create the pods, we just put each container in one pod, just for this example. And we will enable connectivity between the pods. If you see, there are two users that want to access to the voting apps and the other to the results. How we access the connectivity? Identifying the ports where we are going to access. If you see, the users is going to access to the port 80, and for example, Redis will be accessed on that port, and MySQL, no, Postgres, is going to access on this port. So after identifying that, I'm able to create the services. How we can make accessible bulk to other applications? By creating services. If you see here, after identifying the ports, we can easily know which port is going to have a service. In this case, bulk, Postgres, and the ports of app and Result app is going to have services. Now, let's see the deployments. The deployments for botting app and Result app that we scale from 1, you see before, we have 1, we scale to 3. Easy, right? We have now completed creating the Kubernetes cluster application. From container, now we have it in Kubernetes. Okay, let's talk about YAML. Now, if you see a lot of YAML over there, so a YAML is a declarative way to write what we want, and Kubernetes cluster will take actions to make it real. If you see, this is an example of a YAML for botting up, where we just have defined the container in that part for botting up and call an image, and we identify the port where it's going to run. In this case, the port 80. Now, we are going to enter into Kubernetes operators. But before that, we are going to show the Kubernetes architecture. I'm sure many of you know already some of these components. We are not going to focus on all these components, but I'm sure most of you are familiar with that. However, I would like to highlight the API server. The API server is the front end of the Kubernetes control plane, which receives requests, processes them, and stores the desired state in the cluster in the etcd storage, in that component there. Now that we know what the API server does, it's time to talk about Kubernetes operators. We saw that in Kubernetes cluster for chips and chocolates, scaling an application is easy, right? We did it from 1, we put scale, we scale to 3. In this case, we can just make it in this way. With a single command, we can scale our applications. If we want to 4, we scale up. We want to 2, we scale down. What about applications that store data, like PostgreSQL? We are talking about stateful applications. These applications with critical mission, which critical mission is to store data in database or in a file system. We're talking about these stateful applications. Deploy databases are a good example of stateful applications. In Kubernetes, deploy a database should be really easy, like we saw it. We just need to create a deployment with a database like Postgres. For example, we put it into the pod and in the deployment, and we can scale up or scale down. And we have a single instance running into the cluster. We can also provision volumes to store data. We are talking about store data now. But with just a single instance, because it has a persistent state, our life becomes more complicated. This becomes more complicated when we talk about the day 2 of the Kubernetes application lifecycle, like this, when we need to manage and continuously optimize our application. We see now that we are talking about backups, upgrades, recovery, replication, and other common production tasks. Running databases and keep it running, managing over the time in the day 2 of the Kubernetes application lifecycle is really hard. Kubernetes have less tools to direct manage, recover, and scale this kind of applications. And the human operator has to do this. The human operator, the database administrator, do resize, upgrade, backups, and for the databases. And that is really hard. So Kubernetes operators enter in action. With Kubernetes operators, we can extend the Kubernetes API. Did you remember in the architecture of the Kubernetes? So we can extend that part to add new capabilities in Kubernetes, things that Kubernetes cannot do. By extending the API of Kubernetes, we have more specialized operations that are not covered by the API standard of Kubernetes. We also use it to integrate Kubernetes with other tools. But how the API is extended, how we make it possible, how we create new resources in Kubernetes. By two main things. We create a custom resource definition, CRD, and a custom controller for specific applications. To understand this, we are going to do an analogy of a cooking analogy. Let's think of Kubernetes as a cookbook that comes with a set of predefined recipes, resources, for example, dishes like pods, deployments, and services. The custom resource definition are like adding a new recipe to this cookbook. For example, dragon fruit salad. I'm adding a new recipe to this Kubernetes cookbook. And the chef is the only person who knows how to make it delicious. In this case, the chef is the custom controller for that specific custom resource definition. If we see how it looks, how a custom resource definition looks, it looks like this. It's a very huge file where we also define the behavior of a new type that we want to create. If you want a new object in Kubernetes, you can just create and define the behavior of that. In this case, the kind of this custom resource definition is a cron tab. It's a name that I added for that specific CRD. So, and this is the behavior. What I'm saying here, that the behavior of this cron tab is going to be just to execute an image every 5 minutes, and just that. Very easy and small custom resource definition that can be more complicated, like executed backups, restore backups, and many more complicated things for stateful applications. And after we execute this custom resource definition, we can treat this new object as some other objects in Kubernetes, as a default object. If you execute MySQL cron tab, but kubectl apply, and you get the cron tab as an object, you will have it there ready to use it. What is a custom controller? How it works? Kubernetes itself has a control loop, which is going to compare the desired state with the current state of the cluster, and is going to try to reconcile these differences. It's always acting like that. But a custom resource is the same control loop, we can say, but for that custom resource definition that we created as a new object for our new object in Kubernetes. And if you want to know more about how or what's the difference between Kubernetes operators and with Kubernetes with operators, you can download this GIF. I made it, and you will see step by step what's the difference between them. So I leave you in case you want to download. It's very nice because you will see also another element that in Kubernetes operators, you will see the operator lifecycle manager that is going to see all the states of our operator from the beginning until the end. But you will see in that graphic, in that GIF, step by step, what are the differences between running with operators and without operators in Kubernetes. How do I create operators? So there is already a framework called Operator Framework to create operators. So we take the SDK, good practices, and other tools that are already defined in the Operator Framework. So you can access this web page to see how to create a new operator. We also have something similar like Docker Hub, where there is a lot of images for Docker for operators, for Kubernetes operators, which is called Operator Hub. You will find several tools, several operators that are already created for different categories. Databases, for big data, for networking, for monitoring, for security. And if you want to create your operator by yourself, first check if there's already there, so you can contribute maybe to that operator instead of creating a new one. Capability levels. Like many other software, also the operators have capability levels where you can see in which level is each operator. Most of them that are in the operator hub are reaching the level 4 and the level 5. This is the maturity of each operator. You will see here, for example, for Percona operator for MySQL, we developed this operator as an open source. We are reaching the level 5, which is autopilot, where many things are made automatically. And to put ourselves in the time where we are talking about when these things born and all that, I did this timeline. So in 1995, our database is just born. MySQL and Postgres were open source. Then Kubernetes appeared in 2014 and 2015, the version of Kubernetes 1.1. Now Kubernetes has a birthday. It's the 10 years of Kubernetes in June. In 2016, something interesting happened with the team CoreOS. They give the support for the first Kubernetes operator. So from them, many Kubernetes operators start to appear for databases. For example, in 2017, MySQL and MongoDB released the first Kubernetes operator for databases. And then in 2019, we as a Percona also released our first operator for MongoDB. And since then, many Kubernetes operators also appear, like Cloud Native PG was closed before, but they opened the code in 2022. And to see a more interesting timeline observations, in 2015, Kubernetes, we say, was for the brave, because some of you was doing it, but not everyone. We were a little bit afraid to jump into Kubernetes. In 2016, AWS EKS is running, yeah, was released. In 2018, Kelsey Hightower, who is a very recognized person in the world of cloud native, say that Kubernetes supports stateful application workloads, but he doesn't. In 2019, Percona operator for MySQL and MongoDB released our operator. In 2019 and 2021, databases on Kubernetes are for the brave. Kubernetes was not for stopped to be like very complicated, but now running Kubernetes for databases was the thing that was a big challenge. 2022, Data and Kubernetes, which is a big community for many people that is running stateful applications on Kubernetes, says that 70% of the companies run stateful applications on production. And that was a big thing for us. And also for me, was a big surprise that many people are running databases on clusters on Kubernetes in production. In 2023, Kelsey Hightower admits that running Kubernetes operators for databases is OK. Kelsey knew that we needed to work more for overcome these challenges. And with the time, it became possible to make it. Now we are running databases on Kubernetes. Is it still for the brave, we can say? No, because many people are doing it, but there are some implications on it. And it is not for everything, but everyone can try it. You can use Kubernetes to run production databases efficiently if you know or your team have expertise in Kubernetes, also if this is a small database, and you need automation and scaling, and you have already operators running, things that are already automated. But it's not a good idea to run Kubernetes operators when you are new in Kubernetes, or your team is new in Kubernetes, you have huge databases, you have performance sensitive, like a bank or companies in finances, and you have manual deployments. And in case you want to try our operators, we have operators for MySQL, MongoDB, and PostgreSQL, open source. We believe that open source should be open source from the beginning until the end. And if you want to try and give us feedback in our operators, or we want to use it, here you have. And now we are working a very nice tool to run databases in Kubernetes cluster through a graphical user interface that you see there. So you can choose just the database that you want, and it runs over Kubernetes operators in the behind. It is called Percona Everest. If you want to try and give us feedback, also this is here. Yeah, this is for the feedback for Percona Everest that we are running, and that's all. Yeah, thank you.